In the last video, we looked at finding limits graphically and numerically. When we were looking for the limit as x approached a specific value, like in this very first case, x is approaching 2, we went to the graph and we looked as x gets closer and closer to 2, right, what's happening to the y values. Well, when we're approaching 2 from the left, it looks like we're heading towards this lower y value. We could call that 1 if we had this labeled. And as we're approaching 2 from the right, it looks like the function is getting closer to the value 2. So what can we say about what's happening to f of x as x gets closer and closer to 2? Well, we can't give a definitive answer here. It depends on which side we're coming from. We'll introduce some notation in a later section, one-sided limits, so we can say that if you're coming from the left to approaching 2, the limit is 1, and if you're approaching 2 from the right, the limit is 2. But for now, we have to say the limit doesn't exist. And we often use DNE for does not exist. Okay, so from here on out, we'll use the abbreviation DNE for a limit. It's sort of like saying a function is undefined at a specific value. There is no such value. We cannot figure it out. It's not that we don't know how to find it. It's that it doesn't actually exist. All three of these cases, actually, the answer is going to be does not exist. We just want to show you the scenarios under which that might happen. So in the second case, again, x is approaching 2. You can see if I'm approaching 2 from the left, this function is growing and growing and growing without bound. And if we're approaching 2 from the right, this is getting lower and lower and lower without bound. And certainly these two limits don't agree, so we would once again say does not exist. Now, there are going to be cases where we can say limits are getting infinitely large. The y values are getting infinitely large, and we can say that the limit is approaching infinity, and we'll again introduce some better notation later down in the semester to deal with that. But in this case, no matter what introduction, whatever notation or concepts we introduce, this limit won't exist. The left and right-sided limits aren't agreeing. There is no single value that g of x is approaching as x approaches 2. Now, h of x, right over here, it's an oscillating curve, and in theory, this isn't a perfectly drawn curve, but the idea is that the x values are actually not decreasing. So even though it may not look like these values are all the same, let's just assume that the y is just bouncing back and forth between these values. No matter how much you zoom in, you're just going to see that constant oscillation between the negative and positive values. And at any specific point in time, this function does have a fixed value. Its domain is all real numbers. But there is no particular prediction of what it's going to be exactly at 0. Now, you might think it's going to go through 0 at 0, but there's no way to tell here. If we have continual oscillation, we'd say this limit doesn't exist. This is not one that we're going to see a lot of this semester, but it's certainly something that can happen. There are lots of applications that have this kind of oscillation, and no matter how much you zoom in, the function never really settles down. Okay, so we looked at a few of these cases. Let's look at a case like this one here, where again, x is approaching 0. We're going to look at what's happening as x approaches 0 from both sides. And we can see in this case that both of these, the curve on both sides of 0 is getting infinitely large. Now, technically speaking, we currently have to say this limit doesn't exist. But just like I said, there's going to be some ways to handle some of the one-sided limits later. We'll introduce in a later section also the idea of infinite limits. Later, we're going to give a sort of more complete answer that the limit as x approaches 0 of f of x in a case like this is infinity. Now, this is not a contradiction of does not exist, because infinity does not exist, right? There is no actual infinite answer that this value is approaching, but does not exist doesn't really tell us a lot. So we want to, right now, just say whether or not a limit exists or not. We will be looking in the future at dealing with cases like this, where we'll be able to say more than just the limit doesn't exist. Yes, it's true the limit as x approaches 2 doesn't exist. It never will. But we can predict what's happening if you're approaching 2 from the left. We can predict what's happening if you're approaching 2 from the right. This limit here of g of x will never exist. No matter which side you're coming from, they're not coming together, and the same is true with h of x. But we will introduce a way to handle infinite limits a little bit later in the chapter. Okay? So from this section, you're going to focus on finding limits graphically. We'd provide you the graph. You might have some open and closed circles. You might have some disconnects. And then we have to deal with the numerical approach, where you might have to test values just to the left, just to the right. Hopefully on a quiz or a test, most of those computations would already be done for you, and your job would just be to interpret them.